All right, so we are going to talk about factoring, and more factoring. So factoring is a huge, huge deal in Algebra 2, especially as we move forward, and it's a very strong skill to have, and it can shorten your workload a lot if you're efficient at it. So just to quickly recap, what does factoring mean? Well, if you recall, everybody in this class knows how to distribute. So if I wrote something like 2 parentheses x plus 4, and I asked you to simplify that, you would say, oh, okay, well, I'm just going to multiply the 2 to the x and the 4, and I get 2x plus 8. All right, so factoring is basically reverse distributing. So now what I'm going to do is I'm going to give you this problem, and basically I'm going to say, hey, I want you to undistribute it, which is the same thing as factor it. So I want you to factor it means I want you to take that 2 and pull it back out. And that's a harder trick to do because it kind of makes you have to invent parentheses because you have to think in your head, where am I headed with this? So if I remove the 2 from the x, the 2x and the 8, that would have to be shown as 2 times the quantity x plus 4. So I'd have to take that whole sum and double it, not just the x. So it's a little bit more challenging because it's kind of backwards thinking, but again, very useful skill to master. So before we even talk about different kinds of factoring problems, I want to review the terminology that goes behind it. I want to go over the terminology. Okay. All right, so there's basically 2 really popular kinds of problems you factor. The first was called binomials, and just like bicycles, 2 tires, binomial means 2 terms. So for example, x squared plus 5x, I can't combine them. They're not like terms. But there's 2 of them, so I would call that a binomial. Then we have trinomials, which obviously tri means 3, so 3 terms, and again, those are very popular. So x squared plus 5x, add on a constant like 6. That's a trinomial. For anything else, I just refer to them as polynomials. Poly just means many, so pretty much everything is considered a polynomial. It's just binomials and trinomials are really popular, so they get their own special names. But if we have something that's more than 3 terms, I just refer to it as a polynomial. So we only factor polynomials that have 2, 3, and 4 terms. We don't go above that. So hopefully that kind of gets you in the idea of, okay, what's the expectation here? All right, so let's start with factoring steps. So if you're factoring a binomial or a trinomial, or a polynomial for that matter, you always want to start by seeing if there's a GCF. If you recall, that stands for greatest common factor. So for example, number 1, they both have an x in common, so that is the GCF. I would need to factor out the GCF or reverse distribute it. So you're always going to do that pretty much for any problem. And sometimes there is a GCF, sometimes there's not. But I am going to make a little note here that unless you have what's called a difference of squares, which is a very special binomial, if you do have a difference of squares, you can go further, and you should. But if you don't have that special scenario, your binomials are done after the GCF. You cannot do anything else with those. And we'll see an example of difference of squares and an example of something that's not difference of squares, and then you can see the difference. All right, so let's say you did the GCF and it's a trinomial. That's great. If you recall, standard form of a parabola is ax squared plus bx plus c. So if a is 1, in other words, if you don't see a number in front of your x squared, you can be lazy and use this little shortcut. You're going to find 2 numbers that add to your b term, that would be the middle term, and multiply to get you the c term, or your constant. All right. So you find your 2 little mystery numbers, and then you can just set up your answer as x plus whatever the first number is, and then x plus whatever the second number is, and you're done. So it is a huge time saver, but the criteria has to be met. So that's only good if a equals 1. All right, so as soon as I put another number here in front of x squared, that trick, that's out the door. We can't use that. So that's where kids mess up a lot. They try to use this trick for every scenario, and you can't. So you have to kind of realize if I have different scenarios, I don't have the same rules necessarily. All right, but if a is 1, absolutely use this. It saves so much time and effort. All right, so I have several review problems here, take you back to your Algebra 1 days possibly. So we have definitely a trinomial, right? And you can see that A is 1, which is great for us. So everyone's taught a little bit differently, but I've always made myself a little X just to kind of keep my data organized. And I put my C term on the top. Again, just a preference thing on my end. And I put my B term down below. And I'm trying to find numbers that multiply to 7, but add to, that multiply to 12 and add to 7. And there's only going to be 2 numbers that do the trick. So it's not like you're going to get different possible answers. All right. And sometimes there's no numbers that do the trick. And if that's the case, that means that we would write the word prime, which means it's not factorable. So if there's no 2 little magic numbers, it's not a doable problem. I'm not saying that you can't solve it if there's an equal sign, you can't factor it, that's all. So obviously there are 2 numbers, right? 3 and 4. And it doesn't matter if you write 4 and 3, it's the same thing. And then I use my little shortcut. Once I know my magic 2 numbers, I go ahead and set up x plus whatever the first number is, which is positive 3, and x plus the second number, which is 4, and I'm done. That's factored. And the only way that you'll know if you factored it right is, you know what, FOIL it back out and see if you get x squared plus 7x plus 12, and you will. So that's a really quick way to check, did I do it right? So factoring is backwards FOIL, backwards distribute. So, you know, you can just always do distribute or FOIL and check your work that way. All right, number 2. Now, if you notice, A is not 1. So that's one of the first observations that you need to make. So that kind of makes you halt. A lot of kids will do this. They'll write 36 and 21. And right there, it's not going to work anymore. Okay, it does not meet the criteria to do that. But that's okay, because technically my first step should be GCF. And absolutely, there's a GCF between these guys, and it's 3. So we want to reverse distribute a 3. Now this is not going to play any more role to us, all right? All we're going to know is, you know what, whatever I get my answer, I need to remember there was a 3 out front. So we're just going to pretend that that's not there. So here's what I do. I just kind of draw a little arrow and I put the 3 where I'm going to write my answer. All right. Maybe this will break down further, maybe it won't. It will. But now I can make my little X and I can use that shortcut because now my A value is 1. So I'm just focusing on this guy right here and pretending the 3 is not even there. So again, my numbers are 12 and 7, and this is the same problem we just did. And we know the numbers are 4 and 3. So I'm going to put x plus 4 and x plus 3 in my parentheses. The only difference is this one has a 3 out front, this one didn't. Well, that's okay. So actually what we just did is we went from standard form to intercept form is really what's factoring is doing. Okay. Number 3, it is a binomial. So obviously the first thing I'm going to do is look for a GCF. So between 4 and 8, I can factor out a 4. And x squared and x, I can factor in x. And y and y, I can factor out a y. All right, so we have to kind of realize, well, 4 divided by 4 is 1. If I take an x out of an x squared, that leaves me with an x. Y divided by y, that's just 1. So I just write x for the first set. And then I do it again, 8 divided by 4. And then x and y divide by themselves, that's just 1. So that's going to be my answer. There's nothing else I can do that is factored. All right, let's do it again. So we have another binomial. I have 12 and 18. So if you think real quick, what is the biggest factor of 12 and 18? It should be 6. Between p cubed and p, I can take out a p. R squared and r cubed. I can actually take out an r squared. So I want to take the most out that I can. Do a little division here. I get 2. P squared, and the r squareds will just become 1, so I don't need to do anything for that. And then 18 divided by 6, that's 3. And p over itself, that's 1. If I have r cubed and I take out r squared, that leaves me with a single r. And I'm done. There is no more factoring to do. Now, number 5 is a special binomial. So if you notice, p squared, that's a perfect square. So anytime you have an even exponent, like p to the 4th, p to the 6th, p to the 8th, these are all squares. So squares mean exponents that are multiples of 2. All right, so that's really important to realize, and we need to start looking at numbers like 100 and realizing that's a perfect square. So those are key patterns you want to pick up on. Other numbers, so if you see like 4, 9, 16, 25, 36, you want something to go off in your head and realize, oh, that's a special number. That's a perfect square. Knowing those things and being on the lookout will make you much more efficient. All right, so what we can do is get crafty. Because this is a difference of squares, that's the only reason I'm doing this. I can actually insert a 0p into the middle, and now it looks like a normal trinomial. Right? And again, why am I doing this? Because it's a difference of squares. If it wasn't, I wouldn't be doing this at all. I just couldn't do the problem. Okay, so it's a very special circumstance. Adding a 0p does not change the value of anything. I have not broken any rules. I just reformatted the problem. And if I can use my shortcut because a is 1, so I can use my little shortcut trick. So I'm looking for factors of negative 100 that make 0, and that would be negative 10 and positive 10. So according to my rules, I can just set that up as my answer. And I don't typically write p plus negative 10. I just write p minus 10 and save myself a little bit of writing. All right, so that is factored. And again, if it wasn't a difference of squares, meaning subtraction of 2 perfect squares, I could not use this trick at all. All right, so number 6, 9 and 64 do not have a GCF, but you want to pick up on the fact that these are very special numbers. They are perfect squares. So we have ourselves a difference of squares. All right, now I am going to use a lazier method. All right, because a is not 1, I can't use that little shortcut method, but that's okay because it's a difference of squares. It has its own little trick that makes it very quick. We're going to take the square root of 9. All right, we're going to split it into each parenthesis and it goes in the front. Because 9's in the front, we want the square root of 9 to also be in the front. Then we're going to take the x squared and we're going to divvy it up. So you get an x and you get an x. So if you notice, 3x and 3x, they make 9x squared when you multiply them. So that's what happened to that 9x squared. When you have a difference of squares, you're always going to have a positive and a negative. And then we're going to square root the 64. So we get 8 and 8. That is factored. So ideally what we're doing is we're taking the square root of the first term and the square root of the second term. That's really all the math that we have to do. So I do not have to put the 0x in the middle. I could, and then I could show you a long method to do it, but this is going to be the outcome always. So I might as well just show you how that's going to work. And again, this is for difference of squares, which are very, very special. All right, now 7 is back to a normal trinomial where a is 1, which means I am clear to use my little trick. So we're looking for factors of negative 24 that can make us negative 10. So it looks like possibly negative 12 and 2. Check it real quick. Yep, that works. And then just set up the answer. So those are the ones that I'm going to do with you. And I actually like you to try number 8 and 9 yourself. And if you happen to notice, yeah, A is not 1, but if you notice, they both have a GCF. So let's see if you can make that work. All right, so you can check your answer for A. You should have factored out a 4. And the resulting trinomial, A is 1, so you're welcome to use that little shortcut. So your magic numbers would be negative 1 and 3. And the only difference is you have to put that 4 back on the outside when you're done. And then number 9 was meant to get you to think a little bit. So obviously you can factor out a 10. All right, that leaves you with r squared minus 5r minus 14x. we can't go ahead and make our X and use our little shortcut because it's not in the proper format. So this number needs to be a constant, and it's not. It has an X with it. So we have to be done at this point. So it has to be in the pattern where you have like, you know, an R squared and then an R or something along those lines. But the last number has to be a constant. So that's all I'm going to do in this video. In the next video, I'm going to take you through a new kind of problem that you probably have never seen before and show you the trick around that problem.